In this video, we're going to talk about another reaction of alcohols, and in this case, we're going to make esters. So this is called an esterification reaction. So with esterification, what you're going to do is you're going to take an alcohol and react it with a carboxylic acid. And you will need some kind of acid catalyst. Oops, I don't need brackets there. As well as some heat to make this reaction go. This is an equilibrium reaction, so the acid catalyst and the heat help push it towards products. What's going to happen is you're going to take the carbon chain and the oxygen from the alcohol, as well as the carbonyl and the alkyl group from the from the carboxylic acid, and this is where you're going to make your new bond. So you're going to make a new carbon-oxygen bond. So again, we've got the RO from the alcohol, and then we have the carbonyl and the other R group from the carboxylic acid. So here is your ester product. The byproduct is H plus OH, which is water. So that's always a byproduct of the esterification. So really the only thing you need to think about here is what's the alcohol, what's the carboxylic acid, and put your two pieces together. It's also very common to, instead of using the carboxylic acid, first make that carboxylic acid into an acid chloride. By doing that, it helps the reaction move towards products again. The acid chloride is more reactive than the carboxylic acid, so the extra step will usually give you more products in the end. So if you start with a carboxylic acid, react it with sulfonyl chloride, you replace that OH group with a chlorine, and now you have your acid chloride. So now I can react this with some alcohol. Again, I'm going to take the oxygen and the carbons from the alcohol and the carbonyl and the R group from the acid chloride to make the ester. And here the byproduct is HCl. Let's look at a couple of examples. First, I'm going to give you two reactants, and we will see if we can draw the ester that's produced. So HCl is our acid catalyst and heat. So we're going to have 1, 2, 3, 4, 5 carbons from the alcohol, plus the oxygen, and then plus that ethyl group. Then from the carboxylic acid, we have 1, 2, 3, 4 carbons. And here's my carbonyl. So there's the carbonyl. It's always right next to the oxygen from the alcohol. That's what makes it an ester. And then I do have a methyl group out here on the second to last carbon. And then byproduct will be water. So there is the ester from that alcohol and that carboxylic acid. We can also go the other direction. So if I give you an ester, you want to be able to determine what alcohol and carboxylic acid are used to produce it. So here's the ester. So if I want to work backwards, you're always going to split it up between the oxygen and the carbonyl carbon. So then your two pieces, the carbonyl carbon and the carbons attached to it, become your carboxylic acid. So you add on the OH. And then the alcohol comes from the other half. So there's the oxygen from the ester, and we'll add a hydrogen onto it to make it the alcohol.